terms of whether or not you're getting a ring of maxes or a ring of minimums, I have Z double X and Z double Y both up on the board, so we could use either one, okay? If you're at one of these points, then cosine is 0, so that goes away. And this product will be negative, and this will always be positive. This will always be positive, that's going to always be negative. So it's going to matter on whether or not sine is positive 1 or negative 1. So at pi over 2, if pi over 2, sine is positive 1. So so at values where the square root of x squared plus y squared equals 1 pi over 2, z double y and thus z double x, negative times positive is going to be negative. What kind of concavity do you have?
Must be
if it's
downwards.
negative? You have concave down, right? So we're going to have a ring of maximums, which is what we're seeing in the graph. But at the values where the square root of x squared plus y squared equals 3 pi over 2, then I'm going to have negative times negative, because sine is equal to negative 1. Negative times negative will be positive, so z, y, y is positive. I have concave up, and I will have a ring of minimums. And then it'll just keep alternating back and forth. So I did remember something about this whole big mess cleaning up nicely, and that's the case, that if you're on those rings, this makes all the cosine terms cancel out, and then you know sine is either positive 1 or negative 1, and you can kind of reason out where you're going to have rings of maximums and rings of minimums. So let's write up a quick little summary. This was one of the messier ones, or if not the messiest one out of our little set. Okay, so our little summary is at 0, 0, zx and zy are undefined. There is a minimum with a sharp point at 0, 0, and my original function was sine of the square root, and so sine is equal to, so that point is actually at 0, 0, 0. Because the z's are going down to negative 1, it looks like. Okay, so that's what's going on at that critical value, and that at all values on the circles, x squared plus y squared equals, okay, so 1 pi over 2 gave me a max, 5 pi over 2 is going to give me a max, so 4n plus 1 pi over 2 will be maximum points. And then at all values on the circles, x squared plus y squared equals 4n minus 1 pi over 2 will be minimums.
Okay, why I changed it to a 4 from a 2 is that this is true for 1 pi over 2, for 5 pi over 2, for 9 pi over 2, etc. Whereas this is true for 3 pi over 2, 7 pi over 2, 11 pi over 2, etc. So 4 times 0 is what? 0 plus 1 is 1. 4 times 1 is 4, right? What's 4 plus 1? 4 times 2 is 8. What's 8 plus 1? 4 times 2 is 8. What's 8 minus 1? 4 times 1 is 4. 4 times 1 is 3. Okay? Right? So, despite all that mess, we at least do have a nice little summary, which is backed up nicely by our graph. And it brings up the point that you don't necessarily have to have individual single points as mins and maxes. You could have, like we had here, a whole ring of mins and maxes.